Hello and welcome to Practicalli with me, John Stevenson. Thank you very much for joining me on this bright and slightly damp morning for me. Hope you're having better weather wherever you are. And today we're going to cover some more concepts we've been building on, bringing a lot of the things together that we've done over the last few broadcasts. We're going to build a web application in Clojure. So it's going to be server-side web application. We're not using Clojure script just yet. But we'll build a server. Well, the server's already built, and we've got a user interface using Hiccup, and we've got routing with Cojure. And then we're going to start doing some SQL development. So we're going to use a relational database in the back end, and we will continue building this through a series of broadcasts. So you can take it, so you can kind of understand the progression of the development of this particular application, rather than just seeing the finished product. You can kind of see how the design decisions have come along over these next few videos, hopefully. Okay, and so this is kind of the user interface we're going to look at and show you how I did it so far. Just before we start, just a reminder that all the videos and everything we've done already are in the live broadcasts. All the work I've been doing on the books for Clojure Together, there's reports there of what I've been doing, all the work that's been going into that. And so thanks very much for everybody who sponsored me through Clojure Together. And then there's books. Again, I'm putting all the latest work we've been doing in the broadcasts in the Practicalli Clojure book, and also the web specific stuff in the Clojure web apps book as well. So there's a lot of new things in there, and there's a lot more content ideas to go in there and add as well. If you want to contribute, then feel free to click on any of these links, and they'll take you to the ideas, so the links, and you can go in and add some feedback there and suggest some topics there as well, and I'll obviously do my best to get them done. And if you want to contact me, then there's there's the Clojure Slack community, so you can talk to me on the Practicalli channel, or you can message me directly if you want to, if you're not keen on asking in public. And there's lots of other really interesting channels on there, so you can get a lot of help via that way. And there's other ways to sponsor me and motivate me and keep me going with all these broadcasts. All the sponsorship is very much appreciated, and all the likes on YouTube are very much appreciated. I think we're close to getting up to 600 subscribers now, so it'd be nice to get 1,000 by the end of the year. But let's see what we can do about that. Okay, so banking on Clojure. I started doing this before the announcement of Nubank joining up with Cognitech. Cognitech being the stewards of the Clojure language. So they do a lot of the tooling around that, the kind of official tooling, as well as the Clojure library, Clojure language itself. They're teamed up with Nubank, which is a huge financial services company in South America, and they do a lot of work with. They've got like 600 developers using Datomic, so they're going to combine their resources to do even more great things with Datomic, which is the Clojure database. So one potential thing we can do with this application is also, instead of doing it on a relational database, we can also try and do kind of banking using Datomic database as well. This is a live application, but it's not actually running yet. I switch it off when I'm not actually doing anything, and it's actually in the staging environment as well. So we'll walk through some of the deployment steps as well, and you can see exactly how I've got to where I am so far. So if you go to the Practicalli .github.io, and it's a Clojure web apps And underneath projects, I've got some basic information about kind of setting up application servers, and I'm starting to add some more stuff about relational databases. So there's lots of different relational databases you can use. Although kind of H2, I used to use HSQLDB as well back in the past. I think they're very similar. So H2 is an in-memory database we can use. And this is really useful for having a self-contained development environment. So basically you can just have H2 as a dependency, and this is the driver, and basically use it through the next JDBC, which is the kind of the de facto library to use with JDBC and SQL queries. And you don't need to install a database server. So it's basically you can just have a GitHub repository that is your entire project with a database inside there as well. And the files are actually written to these mv.db files. So all the database is already self-contained in a file, which you can also check into GitHub as well if you want to, or put onto an S3 bucket. Excuse me a second. There we go. And the other kind of database that's very common is a Postgres database as well. So we're going to use Postgres locally, but also as Heroku Postgres. So Heroku is an application deployment platform. It also has services like Postgres, so you can basically just provision at a click of a mouse or a command line. You can just provision a Postgres database and start using that straight away as well. So it's another way to have a very self-contained, it's like low install development environment, because you can just use Postgres on the cloud, and you can do that for your testing, dev and production environments as well. So you can have different databases for each environment. And relational databases, it used to be that we all used Clojure Java JDBC, but now there's a much more improved, according to the author of the Clojure Java JDBC, the next JDBC library is kind of like becoming the de facto, if not already the de facto library that people use, especially for new projects. And it's a very nice project. It's very well written, and there's some great kind of details on how to use it. The Getting Started guide is very detailed, and that's we'll be picking out some useful information from that as we go along. And it's pretty simple. You can just include the next JDBC as a dependency, and then start building things either in the REPL or in a Clojure project. So there's a little guide here just to show you like how you use it in the REPL and how to use it in a Clojure project. So in the REPL you can just require next JDBC, and let's do this in a REPL. Projects, Clojure, that's not what we want there. Database access, almost. There we go. So I created a project already, and if you look at the deps.edn file, it's got, as well as Clojure, obviously, it's got the next JDBC, and it's just got the H2 database in there already. And nothing else. This is just a standard Clojure new CLJ new project. And if I do Clojure, I'm just going to start it with using the Rebel readline UI, because it gives a much nicer Clojure command line experience. And I already got this in the history. Rather than typing it all out. So basically we require the next JDBC, And so that loads in that library. It also has like a type, a class name that it uses to reference which driver to use. So we can define this database connection specification. So this DB2 is telling JDBC that it should use the H2 driver to be able to talk to the database. And we're just creating a database name of address book. So that's the database specification, and because H2 doesn't require any authentication or authorization, we don't need to supply any kind of username and password. So it's nice and simple. Obviously, if we were going to use Postgres, then we'd specify username, password, and other things, and kind of a URL or a location of where the server is running. So we've defined the database connection, and then we've defined a data source, which is sort of the actual connection to that database itself. So that's up and running, and then now we can create a table. Oh, there we go. So we can create a table here. So we're just really executing SQL statements. So this is a normal kind of standard SQL statement. So we're creating a table called address. It's got an ID, which is an integer, which is also incrementing, and that's also the primary key. We've got name and email addresses, which are just variable chars. And we're just going to execute this against the data source. The data source being the JDBC connection to the H2 database. And so now we've got a table there, and if we actually looked on the file space, we'd see that there was now an address.mv.db file that's been created, and so that file is our database. And then we can do where we go. We can insert a new record in there as well. So we're going to again execute another SQL statement to the data source, and so we're just inserting particular values into the address table, name and email. So again, this vector is just contains a string of a particular SQL statement that's going to run. And then we see that it's indicating we've actually updated the result of that, and so we know it's actually done something. And then we can obviously we can select from there as well. So we go in and select what we just created, and it's returning the records. There's only one, but yeah. So it's really quick and simple to actually start using a relational database inside there without having to spend time setting anything up. And you can obviously then start kind of evolving the relational database design alongside your Clojure code straight away. So it's really easy to do that in the REPL, and obviously you can do that inside an editor with your with a project as well. And so the project is pretty much the same. Yeah. So the project, you're just creating. So you just basically add next JDBC as a require in your namespace that's going to have files in there. Now this is a very simple way of doing things. So just specifying a DB specification and a source, and then executing each time. So each time it's going to create a new connection, which is not very efficient. So we're going to look at ways to make that more efficient as well. So this isn't exactly how you do it for production, but it's a quick way to get started, especially if you don't have a database design already, which in our case we don't have a database design. So we're going to very much do it from the outside in, and so We don't need to worry just yet about making this performance, but it's very easy to do that. And we can also use connection pooling at a later date as well to improve the performance of using our database. And we've also, previously we've covered application servers. So this is how we organize our application servers. So we have like a container or physical hardware as the operating system. And then we got a Clojure application that's running an embedded application server. And hopefully we'll have some logging and monitoring attached to that application server and to the applications running in there as well. And so this is a little bit different to kind of typical Java world where you would have like an application server with the applications embedded into it. So this kind of flips it on its head. But this approach is much more conducive to deploying things on the cloud. And it's also a much more efficient way to do things because you can build smaller services rather than having one big monolithic server that has a lot of resources in. You can deploy this across multiple servers, and it makes it easier to scale up and scale down specific parts of your application infrastructure as well. So I'm not going to go through that. I'm going to jump to banking on Clojure, so you can see where we've got so far. Excuse me. If you've got any questions, please add them into the chat, and I'll try my best to answer them. We've got banking on Clojure. We got it deployed, although at the moment it doesn't actually do anything. It's basically a user interface. There's a couple of buttons that do work, but the actual data itself is just mock data. So the next stage of this will be to connect this up to a database, but we don't have a database, so we'll need to design the database records and then populate with data and do database migrations and so on. So we'll be covering that probably in the next episode. But to start off with, so all the code's in this repository if you want to go and have a look at the code. But basically we've got a basic design of the application, so we're going to do these specifications, which we've already created. So we already did some Clojure specifications, so we're going to incorporate these into the design, and so that code's already pushed into this library. And so we've got some data specifications for customer details and accounts holders, and these specifications will help us design the relational database as well, so that's quite nice. I haven't actually looked to see if there's a way to generate relational database designs from specs. That would be quite interesting. But we'll see. But it's fairly straightforward. These specifications are not particularly complicated, and could probably do with some slight improvement as well. And then we're going to have some functions on using how the banks how we can use that as a customer. And we're going to do some generative testing using the Cojure test runner. I'll spell that wrong. Oops. Okay, so what we built so far, let's have a look. So we've got the application server. This is fairly straightforward. There's nothing different to what we've done before. I'm going to jump to the code to see this as well. So inside source.practicalli, so the main namespace is the name of the application, which is banking on Clojure. And so this has got the system and the routing there already. So that's the so we're using HTTP kits at the moment, but there isn't really any difference in terms of the code if you're using HTTP kit or if you're using Jetty. It just seems to be that Jetty is a bit more conducive to using with some monitoring tools. So we might switch over to Jetty, but essentially it's kind of an engine underneath that we're using, and all we really need to do is change a couple of lines of code and we can use Jetty instead. And in some projects, I think in the Sean Caulfield user manager, there's basically a switch, so you can decide whether you're going to run HTTP kit or Jetty whenever you start up the application. So that's our app server. Then we're using Cojure core for routing. I think it just makes it nice and simple. It's a nice little abstraction over routing. So you've got the HTTP request type. So is it a get, post, etc. You've got the address that you're going to do a request from, and then you've got a handler, a function. Basically, it's just a normal Clojure function that will do something based on receiving the request. And so HTTP kit and Jetty are kind of using ring on top, using the ring specification, which basically turns all the requests from a browser into a Clojure hash map. So basically you're passing a request hash map into each of these handlers based on, it's kind of like a case statement, I guess. It reminds me very much of like a case statement. So so based on which of these are true, so if it gets, so if this is the request, then we pass it on to this particular function. And I put all those to keep the main namespace simpler. Then I've put the request handlers into their own namespace. So we'll have a look at that in a moment. Essentially, we've got very simple routing going on there as well. We might want to evolve this over time, use more of a REST-like approach as well. And then in the rest of this is the system. So we've got stuff we've already done before in previous videos. So we've got an application server instance. So we can monitor, we can have kind of like a handle, a reference to see whether the application is running or not. And we've got start and stop and restart, just to basically start, stop and restart the application server, which will obviously then start our application. And a main that just basically tries to work out what the port is. So what is the port that we're going to listen on for HTTP requests? So we need to have this defined, and so we can either pass the port in as an argument, and so this is the OR expression here, which says we can either use the argument that we find, we can use the an environment variable called port. Oops, excuse me. And so this part is very useful, especially when deploying on the cloud, because the cloud environment is going to give us a port value to use. So we should pull that in. And if neither of those two are passed, it's just going to default to a hard-coded port value. And so if we do forget to call it, it's still going to run. If we forget to call it with a port number or port value, or if we haven't set an environment variable, it's still going to run and just use the default port there. And so to help people use this as kind of some live documentation, then there's this comment block, which basically just shows you how to actually run the application, how to start it, how to stop it, how to restart it. I'll also check how to check if you've set a port value or not. And I don't think I did set that. So if there's no operating system environment variable set for port, then it'll return nil. If it is set, then it'll return obviously the value of that. So that's something we can use. You can also get all other kind of environment variables as well. You can see all the environment variables that are in the system, and you can do the same thing for get properties as well. So that's a really kind of simple, uncomplicated way of doing things. Obviously, as we evolve these this application to using more and more services, then it makes sense to actually change this over to use a component system. So we'll also cover like converting this to things like mount and integrant. But you can still get, even at this kind of minimal stage, you can still get application reloading, because we're basically, when we start the server, we're going to basically run the server with this reference, this dynamic reference to the application, and the application is defined by this def routes. So our application is basically, it comes into our routing, and then our routing decides where the request should go, and the handlers then return the results, hopefully as a valid response map, and there we go. So because this is a dynamic thing, then all we need to do is just reevaluate our code in the REPL, and things will change. I seem to have a bit of a cough this morning, apologies. Okay, let's have a look at the, well, let's see if it works. Let's run the application first. So I think we've got my REPL running already, so that's good. So I can just evaluate all the code in the file. This is going to evaluate all the kind of namespace and everything else, but not the things that are in the comments. And then I can just start the application just by evaluating main, and this will go off, and basically there isn't I didn't pass an argument, so it's just going to use the default 8080 thing there. And if we go look at my REPL, I can see I've been playing around. This is for errors from when I was doing things earlier. Let's ignore those for now. But basically this is a little message I've got here just to show that the server is started on port 8080. I do that in the start. If you look at the start, oops, where is it? So basically I've just got a Java util date, which basically just creates a date stamp, and I just join that on the string that just basically says what the server's started, and just to confirm just some feedback on what port it's actually running, which is quite useful, especially in a cloud environment. You can kind of see this basically a simplified log statement just showing you that it's actually using the right port. So it's quite useful to have that in diagnosing if you're getting a port value from a cloud environment, but then you're not actually using it or not using it properly, then this is a useful way to get that quick feedback. So you see it's running, and rather than having to stop and start the REPL itself if I do new things, I can very easily stop and start the server. So I can recall those. I can just do a restart. And you can see it shuts down and starts up again, so it's really quick. Again, we haven't really got much going on here. We're not loading in huge amounts of things into the application, so it's really quick to start anyway. If we go to a web page, we could do localhost. There we go. There's the application running. There's an awesome piggy bank application. You can see I'm not a graphic designer by trade, as you can tell, but it's a nice simple kind of website. We can pretend to log in. It's just got a fake login at the moment. It doesn't actually ask you for any login details, and it takes you to this banking on Clojure, basically account overview, and you can go in and transfer money as well. So that's all to set up things, transfer payments and so on. So that's all kind of stuff to set up, but it gives a basic idea of kind of the user interface and the kind of main functionality that we're going to actually build. And when we deploy this to kind of staging, then we can pass this URL to people who are going to use it, so people in the business, and say, is this doing what, does this look in the way that you actually want it to do? Is it got the features and functionality you actually want, even though like underneath it doesn't actually do anything real just yet. Let's go back there. And we can go in and actually, if we do change things, we don't have to restart the server each time. We can go in, let's go to some of the handlers. So we go to our request handler namespace. Then this is basically just lots of kind of HTML at the moment. So there just needs to be some, there can be some refactoring in here to simplify a lot of this and to codify up a lot of this. But essentially we've got some hiccup to be able to build HTML output using Clojure data structures. And so these three libraries, these three aspects of the hiccup library help us build things. And we're also using this ring util response to ensure that things are returned as a response map. So if we look at our welcome page, you can see we've got a title, Banking on Clojure. Let's see. So if we make a change, so at the moment, before we save that, before we evaluate that, let's jump back to the web page. Where is it? Is there? There we go. So here we've got the tagline, making your money immutable. I'm not sure if that's a good thing or not. I think so. It means you can't lose anything. Then if we just reevaluate the function, the handler, then we can kind of see that this is going to change. So just evaluate this welcome page. And we go back to the browser, go back to the welcome page, just refresh, and you can see it's already updated. So we can kind of get a very simple way to get feedback without having to build anything complex into the application itself. So we don't need to start and stop the REPL, we don't need to start and stop the server, unless we're going to add, the only caveat is if we're going to add a new library dependency into our deps. If we go into our deps file, deps.edn file, so if we add a new dependency in here, then we'll need to restart the REPL, but otherwise we should be able to just keep on coding, and even restarting the REPL is only going to take a few seconds as well, so it's not interrupting the development flow, hopefully. And in terms of dependencies, so we've got the web application dependencies here, which is HTTP kits, and you can include these dynamically, which is what I've seen do. If you're going to switch between one or the other, you kind of include these dynamically. But we've got HTTP kits and Ring, so that's the application server, Ring for managing the requests to the application server, Cojure for managing the routing, and then Hiccup for obviously doing the user interface web HTML stuff. And then we've got the database, we've got Next JDBC, and we've just got H2 at the moment. We'll add in Postgres in here at one point as well. We do need to specifically add the database drivers as dependencies, but we don't. But then Next JDBC will just pick up whichever dependency it needs to use to do the requests to the database. Okay. Let's jump back. So that's the application servers. So what I did, rather than have the handlers in the main namespace, I basically refactored those into their own handler namespace, and then just added this namespace into as a require, just as handler. And then we just do handler, welcome page, whatever. And that just takes a lot of the code out of the main namespace, because you can see that in the jump to the request handlers. Source. So there's a lot of code in here. There's 300 lines of code in here. Oh, there's probably a bit less than we're actually using. So there's a lot of design, alternative designs I've put in there. So I'll take those out. But we've still got 200 lines of code, which is our hiccup. Maybe not. Oh, yeah, about nearly 200 lines of code. But some of this is boilerplate, so we're actually kind of also including some little markup generators. So here I've got a media object, which is a type of kind of component in the CSS library that we're using. And basically it allows us to create these, so the media object allows us to create these sections, which are the accounts. So each account in this list is a little media object with its little icon and the title and some details there. So this code builds this. It's using this coin icon as its left image, and then we've got pulling the account type details from the arguments we're passing, and so this is going to be a current account, or it could be a savings account or mortgage account. And then we've got this little lambda, because we're using lambda currency rather than any kind of real currency in this case, and we're just pulling out the account value from that from the argument, and we do the same thing for the account number and sort code. We're just pulling all those details out from a map that we're passing into here, and we're using this hiccup link to provide a link button, a button that's a link to different other parts of it. So we can click on transfer and it takes us to another part of the application. And then we can call this bank account media object from the, not from the welcome page, but from the accounts overview. And so this was like, I think this is a really long piece of code because it had a lot of duplication. So basically we've got the HTML5 page, which can also be taken out as a template in another iteration. So basically it's just including the Bulmer CSS framework, which we're using. So we've got all the access to all the Bulmer styles, which is like all these class styles here that we're using. And so the vectors are the tags, the HTML tags. So we've got body and sections and devs and H1s and Ps. And then we're using the classes, which are mostly from Bulmer library. So we've got the hero body, which puts a nice big title at the top. So this is blue title here that provides. And then we've got this, rather than repeating code, we basically just have a section which calls this bank media object with a map. And this generates the hiccup, which then obviously generates the HTML code for us as well. So rather than like over 100 lines of code, we've got it down to like 30 or 40 lines of code. And eventually we should just have it so it's we just have this as a template that we wrap the section in, and all this is wrapped in a response object. So we get basically a response object we would need to return is again another hash map. So we need to then we'd have a body. So our body is basically this HTML5 that we're passing in. So the web page we're passing in hiccup, and then we have the the headers map. So what kind of content type is this a HTML page, is it a JSON packet, and so on and so on. So this is basically what the response is doing. It's providing this structure and then just taking the argument that we pass to response and putting it into the body of the response hash map. So that makes sure that everything works correctly. And this is something we can put in our tests, which I've done. Oops, wrong button. There we go. So this is the tests for the handler. Let's go with it. So these, I've written a bunch of very simple unit tests for the request handler test. So request handler namespace. So all the handlers have at least one test in them already. And again, this is just using Clojure test, using def test, and I've also got this ring mock, which is really handy. It's a really handy way to actually get a request hash map without having to write it yourself. So we're basically including this as the alias mock, so we can call mock request. We can give it the HTTP protocol we're going to use. So is it a get? Is it a post? And then the address we want to get the request for, and this generates the request object, request hash map, and then we're basically passing that into the welcome page handler from our Practicalli request handler namespace. So we're basically just calling this as a function. We can call our handlers as a function, so they're very easy to test. We don't have to do anything, even though we're using this mock thing. It's not really a big complex mocking framework. It's simply just a way to generate a Clojure hash map, essentially, without hopefully without any typos, because we're basically just saying what kind of shape we want the request hash map to look like without having to actually type it in ourselves. Yeah, so if we just evaluate just the mock request expression, we can see that we're getting this this Clojure map, and we've got protocol, we've got server port, we've got server name, localhost. So this is all the information that gets sent to the server from a request. So if you clicked on a button in the browser, it would send a HTTP request to the server, and Ring would create a hash map with the relevant information in there as well. Obviously, we're not doing it from a browser, so we don't have the browser-specific information in here, but we have all the important information that we're actually going to use. So if there's any particular parameter we're passing as well, we'd include those. But it's very easy because this is all just simple functions. We can just call them and find out what the results are. And we can even go in, and so we're here now. We're calling the welcome page with that request object. We can see that it's actually returning a response map. So it's got status of 200, which is okay. We've got the headers, which we're not returning anything in the headers thing. We're not returning content type just yet. And then the body. So this is the result of that HTML5 call. It's producing a string, which is basically our HTML code, our HTML markup code, and all there as well. So if you weren't quite getting the markup code right, it's very easy just to call welcome page and see the results of that, and see what you can just pull out the body, like I'm pulling out status here, and you can see what if there's any issues in there as well. So it's very easy to inspect exactly what's actually going on in the code that you're writing and the code that's being generated for you very easily. And so here we're just doing something simple, just checking that status is 200. So basically, is it returning an OK result? Is it actually getting the request and providing a response? If we run the tests, yeah, we see run all the tests and they're all working. Hey, that's good. And you can also do that on the command line as well. So we look at that. How are we doing? 47. Ooh. What we're looking for. There we go. So I've defined some handlers. I've covered all that already. We've done some unit testing as well, so we're adding in a whole bunch of unit tests. So that's got covered there. And also you can use Cojure. I've got Cojure set up so you can run unit tests on the command line. I've mainly done this so I can run generative testing as well, and then also use this as the tool as part of the continuous integration we're going to do. So you can see if we don't have, so actually I missed off one of the using the response function in one of the handlers. So actually the unit test did pick that up, so I fixed that since. But it's very easy to just to have a quick sanity check with the unit tests on there just by running bin Cojure, which is part of the repository as well now. And then we've got continuous integration set up. Again, we've covered this already in previous videos, but there's all the details there. So basically we've got a Cojure script that runs test to load in the relevant libraries and paths for testing, and then it just runs Cojure and runs our unit tests, and when we have some, it'll also run our generative testing as well. And then we've just got the Circle CI configuration, and that all worked. So we've got that up and running. Success. So we've got that successfully running. I've also added the Heroku orb in there as well. So we'll have a quick look at that. Oops. So as well as, so we're using Circle CI to run our integration tests. Obviously there's only a handful of those at the moment, but as we add more, then that'll become even more valuable. And then we're going to deploy the application onto, initially we're going to just deploy it onto Heroku. It's nice and simple. So we're following what we call these 12-factor guidelines. If you go to this 12-factor app web page, I'll put a link on the web page, on my web page. But basically some of the things is that you have one code base to track all the revisions in, and you basically drive everything from that code base. So basically we're writing some code in our editor, we push it to our local Git repository, and then from there we can deploy to different environments. So we can have testing, staging, production master, we can deploy to like feature, we can deploy a feature branch and see if that works as well. So it's a very flexible way to deploy things in a very lightweight way. And you can basically show people and get people engaged with your application, especially if you're developing a product or anything with a user interface or anything that people are going to interact with. It's a really good way of getting it into their hands and getting feedback from them early. It's always better to get feedback while you're actually writing features than a couple of weeks later when you've forgotten what you were writing or how you've written it. So it's a much more effective process. And what we've done, rather than push, so each time we're pushing this, it's going to build the application and deploy it. So rather than build it for production, we can actually just, if staging passes all the tests and everybody's happy with it, we can actually just push that onto, promote that to production. So that's what we've done with Heroku. So I've created this Heroku pipeline called Banking on Clojure Web App. And we've got a staging environment where we've just added an application. So I just went on there and created a new application. An application is just a placeholder for where we're going to deploy our application. And I did the same thing for production. So I've just basically called production the name of the application, and then staging is the name of the application with staging at the end. And then when I'm happy with everything that's running on here, so I can go into Banking on Clojure, and I think I switched this off, didn't I? Oops, wrong one, wrong button. Oops, resources, there we go. Yeah, let's switch that back on. Oops. Switch that back on. Ooh, confirm. So if I open the app, hopefully that will start up. Takes a few seconds. There we go. So this is actually live on the internet. Woo! So this is being pushed from Circle CI onto. Let's go. So we've got something. We've got a configuration in Circle CI which will push the application to Banking on Clojure staging environment, and then we can go in and we get people to go and look at the application, see whether it's working, is it doing what they're expecting it to do, and so on, and get some fast feedback that way. And then when we're ready, we can also go and promote this production. I haven't actually done this for a while. Oh, there we go. And it's just going to take, without having to rebuild, what it calls the slug. So basically it builds your application and puts it into container. So it's going to just deploy that into its infrastructure. And so this should be fairly instantaneous. There we go. Oh, we've got a release. And so now we can actually go and open the app in production. It will take a few seconds the first time it's run because it's basically starting to spin it up. And this is where, like, when you're designing applications for the cloud, you should make them as kind of like as lightweight as possible, especially to start up. Oh, there we go. So this is now running in production. There's no staging section in here, so this is the kind of the live website. People can go interact with it, and obviously it does exactly the same thing that staging currently does. And so setting up a pipeline is really, really simple. I haven't used the review apps. So the review apps are, say, if you wanted to build a have an application created for each like feature request or each commit, you could have a new application spun up and built and spun up because you're all driving it from code. So you push commit into the code. It's going to build a new version of your application and replace the old version with the new version. This feature does actually cost money, whether these are free. So that's one reason I haven't actually used it. And also I don't actually need to do that, as it's just me developing. Then I don't need to kind of do that. I've got a staging environment, which is fair enough for me. But if I was developing a major new feature, then having something like review apps would be quite useful. But I can also do that locally on in my developing environment as well. But I am limited on how I can share that as well. I could just create another application and push it to there. That's the nice thing about Heroku, is it's just very simple just to create an application and just push code to it, because they're all basically just driven by your source code. So you basically create, you have your source code, you push, you create a Heroku application, which is essentially a Heroku repository. So you just push code to that and it will build it. Create the slug, set in any environment variables, and then it pushes it to a live running container, which it calls a dyno, and then you've got a live application. So you don't need to configure anything on Heroku except for kind of which build pack you're actually using, and for most languages that's automatically detected anyway, so it's fairly simple. And so the next stage of this is to kind of start developing a database. So I'm doing this, I'm kind of starting to add things into the relational database in here as well. And in the code, I do actually have started some of this. So if we go into the database access test, I've got some tests. So I'm actually using the specifications that we've done already. But I've got I've got a unit test to say, is the spec valid? Comparing it to an account holder. So I've got an account holder that is a specification I've defined, and this should be the same as when we call register account holder. We should get the result of that should be a return of a map which has all the account holder details in, and so we're comparing it against the spec that we've defined here, this Practicalli banking specification spec. And we're also using so the generators, so we don't actually have to think of testing code ourselves. We can use this generative testing here. So we've got spec generate, which will take a specification which is the customer details. The customer details are the argument we're passing to the register account holder. So when we want to register an account holder, we need to give it customer details, which is a Clojure map. And so we've got a specification against that. So we can use that specification and get a generator for it. It's a very simple specification, so we just use the off-the-shelf generators, and then we can generate a particular value for that customer details. See if we get the right one. Yeah, so here we can just generate a map. It's got a qualifier, a naming qualifier on the map as well. So every key has a fully qualified name of specifications banking. So we've got first name, last name, email, address, etc., etc. So this is all the information that we're going to use to pass to the register account holder, and then the result of calling that function should be a account holder specification. So if this works, then they should be the same. So we basically get back pretty much the same thing, except we get an account holder ID. So we're basically just adding that to that. So this is just run as part of the normal unit tests, and it works. It means also it simplifies how we do things. We don't have to pull out specific parts of the test data to see if something is a certain value or not. It just simplifies how we can test it using specifications. And also, because it's generating stuff, it's each time we run this unit test, we're basically testing it with a new piece of data, and so it's much more likely to catch strange edge cases every time we run our unit tests. And so these tests are against the database access namespace. So the functions we're doing here, because it's going to be the database access functions access information in the data. So we're testing that they're pulling out the right information from there as we go. So if we go and have a look at that, so we're starting to build up this database access. Again, this is going to change quite a lot because we're going to make this more production code, but essentially we're going to have a connection initially to the H2 database and create a connection to that, and then we can just I haven't wired it up yet, but then we can just start writing functions that will pull information from the database and obviously update the database. And these functions will then be called from the request handlers to actually do the work. So rather than build in the request handlers into kind of like database work, they're gonna call functions that do that for us as well. So it kind of has a nice layer of abstraction on there and keeps the handlers fairly simple. Okay, I think that's everything for now. I hope you found that interesting. I'm going to keep adding to this section as well. There is a section on here of Ring and Composure, which is the classic content I had with Leiningen. But this is going to be I think it's going to be the main project I'm going to be working on for the next few weeks. So there should be a lot more detail in here. So it should grow nicely. And we'll also wire up Postgres in there as well, and show how to use Postgres, Heroku Postgres. This content needs a bit of updating on this. It's like 5 years old, but I don't think much has really changed in those 5 years. Probably just the versions of the drivers as well. So this has got some information about how to work with Postgres, and I'll add some more content in there as well. And like creating a database model, we'll cover that. And so all these kind of aspects will go into the banking on Clojure thing as well, because we haven't actually got a database model yet, but it will be largely based on the specifications that we're actually going to include. And the specifications we actually did from Practicalli Clojure a while ago. We go into testing Clojure. So in the spec projects, we've got this bank account where we developed step by step. We developed the specifications as well, so you can see how that's done. Ideally, I want to convert this into a library, and what I'll do is also, rather than put this code into the web app, I'll actually extract that into and just pull that from a GitHub, use that as a GitHub dependency. I think that's the next thing I'm going to do. Cool. Okay, well, if there aren't any more questions, I'm going to leave it there. Thank you very much for watching, and I hope you found that very useful. Again, if you want to get in touch with me, then all the information is on here on the Practicalli website. And feel free to ask me lots of questions in the Practicalli channel, especially about how we're developing this. And if you've got any ideas about what you want to see, some people have already kind of mentioned that. I'm going to cover databases. I'm going to cover H2 and Postgres, but also looking at things like Datomic and Crux would be useful as well. So any kind of input on that is very useful. And I'll try not to spend too much time fiddling around with the user interface as well, because that can suck on time very easily. Okay, well, there we go. So thanks very much for joining me, and we'll see you next week. Have a great week. Thank you very much. Bye-bye.